because that's when the recording starts. Okay, so moving on to section 1.4, you'll see why we decided to postpone this lesson today, because it is a rather lengthy lesson with some really important terms in it that you're going to define. Here we go. What's a ray? A line that extends in one direction, but a line by definition extends in both directions.
There is only one endpoint, and on the other side extends.
So is it a line? What is it though? So like for instance, if I'm defining a dog, I would say I need to classify it first. It's an animal that, it's a canine that, it's a, you know what I mean? So what is, you want a picture of it, by the way? That's what it looks like. What is that thing? Because it's not a line. You can't use the word line because it's not a line, right? Feel free to help them out, by the way. We don't need to go Christian for the dogs here. You're not that far off, by the way. We just got to tweak the vocabulary a little bit. What do you got, Ted?
It's a line segment with one endpoint going on.
Same problem. That's a line segment. That's a ray. So a line segment, the way we define line segment is that it starts and stops. That doesn't stop. Well?
A connection between two points that extends in one direction.
A connection.
Basically.
How do we feel about a connection? Sounds like we're on Tinder. Yes, us old people do know about you young kids' little things, like the Facebook and the Instagram, you know, the Google. That's big. Us old people like the Google. And we can find out what all you young kids are into. You know, like Justin Bieber, that kind of stuff, you know. Anything else? So we don't like the connection definition. Can't use line segment. Let's not overthink it. Real simple question, what is that? Don't tell me it's a ray, by the way. Some of you were thinking about that, weren't you?
It's a ray.
An arrow, okay? Not horrible.
A part of a line that.
Stop. I'll come back to you in a second. Part of a line, not a line.
Oh.
Go.
A part of a line that has one endpoint and one end that extends forever.
Which is exactly what you said. The only difference is that you had line instead of part of a line. This is a part of a line. It's not an entire line. Okay. The weird thing about a ray is that it starts at an endpoint. Is anybody else bothered by that?
No.
Really? It starts at an endpoint. But you know what? It doesn't end at a starting point. I changed starting point to initial point, but in essence that's the same thing that Nicole and Krishna said. It's a chunk of a line. Starts at one point and goes on forever in one direction. One direction. Moment of silence. Okay. What are they now? 2 direction, 3 direction? How many ways did they split?
No direction.
Yeah.
No direction?
They have the direction.
I like that.
Thanks.
Do one. Okay, how are we going to name this thing? Well, you guys are probably pretty good at pattern recognition. When we were talking about a line segment, we put a line segment over the top of the 2 letters. When we were talking about a line, we put a line over the top of the 2 letters. So if we're talking about a ray, what do you think we would put over the top of the 2 letters? You guys, that's why you guys are in honors. 2 points with a ray over the top of it. Is that notation AB with a line over the, or with a ray over the top of it? Let me get my pen all ready to go here. Is this the same thing as this? But before we argue about that, let's back up. Ooh, that looks cool on the gray. Sorry, I got distracted. Are these the same thing?
Yes.
Okay. Are these the same thing?
Yeah.
Last one. Are these the same thing?
Yes.
Okay, so these are all, Y is for yes. This one?
No.
What does this mean?
Like the starting point is at A.
And then what? Because if I'm at A, now what do?
It infinitely goes to B.
Yeah, go towards B, hit B, and then just keep walking for a while. Actually, for a long while.
Well, you kind of
Okay, good. Getting crazy here and changing colors. What does that mean, Michael?
It means the starting point is A, and then you walk to A and go forever.
No, say that again. You said it wrong.
What did I do?
You misspoke.
Well, you start at B.
There you go. You said A.
Oh, whoops.
Okay. Start at B,
Go to A.
So I come over here, start at B,
walk forever.
and I walk towards A. I hit A, and then I just keep going. Okay, good. So the ray gets a little bit weird because these are not the same thing, and you have to be careful which one you're using. Also, when you're using the notation, the arrow always points to the right. This makes no sense in our notation. Okay, don't do that. In fact, change colors here. I will give you the international symbol for don't do that. Okay, we good? So we took a line, which extended forever. We chop off one of the sides. We end up with a ray. Then if I chop off the other infinite side, I'm left with a line segment. Or just a segment, depending on the notation or the terminology you want to use. How many points on the ray?
Infinite.
How long is the ray?
Infinite.
Infinite, good. So that notation that we used of just saying AB, it remember is the length of the line segment AB, because you can't measure the length of the ray. You can't measure the length of the line. Only line segments can be measured. Okay, so that was that 4 notations? The line segment, the ray, and the distance. So 4 different things using the same letters. And you can change the name of the ray. The only real important point on the ray is the starting point, which is called the end point. The other point doesn't matter. So if I start here at B and I start walking towards A and I pass C on the way, it doesn't matter. We can call it AC, AB, whatever you want, the same starting point, but any point on that ray can be used to name it. Okay? We good? Awesome. And we're clicking. And we're not clicking. Am I still in pen mode? Didn't mean to do that. So I clicked ahead, but then when I came out of pen mode, I heard, hey, what's an angle? If you read me that definition, I'll come back there and smack you. Go ahead. And the smacking begins. That's an angle. Ignoring the fact that I just put my definition up there, what is that? Sorry about the squeaky shoes today. I can't control it. I can make it worse. So what is that angle? What's it made up of? 2 rays. And what's true about those 2 rays? At? Which is? Forget about B, just if I take 2 rays in general and intersect them, what's going to make an angle? Where must they intersect?
Starting point.
The starting point, which we call the end point. Yeah, okay, so we get that. They share a common endpoint.
It's a little distracting.
Is it? I'm sorry. I'll try not to make any more noise. I'll tiptoe through the whole lesson. The rays that make up the angle are called the sides, and the common endpoint is called the vertex. Awesome. If you have one of them, it's called a vertex. If you have more than one, they are called vertices. V-E-R-T-I-C-E-S, not vertexes. Vertices. Now we need some notation to refer to an angle. So how are you going to name that angle? Mary, what was that? You're just waving your arms in the air? Like you just don't care?
Hey. Yeah. What?
I don't know. I'm just wondering why your arm just went crazy and started waving all over the place.
Yeah.
You were either really excited about geometry, you were trying to stab Morgan. I don't know what's going on. I just want to make sure everybody's safe.
We're good.
You sure? Okay, good. How are we going to name that angle?
Is it angle ABC?
Nice. Good. You want to write out the word angle?
No.
Oh, you
Draw
you draw it?
Draw what?
The angle?
Like, what do you mean? Come here. I won't hurt you. Show me. They don't like that. What don't you like? They don't like the arrowheads. Are you okay if I erase the arrowheads?
Sure.
Okay. Like a surgeon. You like that better?
Yeah.
Okay. How else can we name that angle? I'm sorry?
Angle. Huh? Angle CBA.
Angle CBA. Are we okay with that?
Yeah. There's an eraser.
Thank you. I just erased some blank space there. Pretty scary. You guys know how to use the technology better than I do. Any other ideas? No? Those are the two most common methods we're going to use. Okay, 3 letters. And notice, what do those two notations have in common?
The vertex is in the middle.
Vertex has to always be in the middle. So this is not the angle BAC. That would mean the vertex is up at A. So we've got this. All right, we talked about this already. Sometimes you can use just the vertex. If you've got an angle over here by itself, feel free to just use the angle. Just use the vertex. Angle B. And then sometimes you'll also see I'll put a number inside and you can refer to angle B. Why will this number 2, why will number 2 sometimes not work? Yep.
If you have like more than like 2 rays connected, would that create more than an angle?
Beautiful. So if I have something like this, and you just say angle B, now we don't know which of the 3 angles you're talking about. Are you talking about DBA, ABC, or DBC? So if you stay with number 1 will always work. Sometimes, however, if pictures get complicated, feel free to throw numbers in here and start referring to them as angles named by the numbers inside the angle. Okay, easy so far?
Easy.
Yeah.
Beautiful. 4 types of angles. I have 3 of them pictured. What are they, Vanessa?
Oh, the one on the left is an acute angle, the one in the middle is a right angle, and the one on the right is an obtuse angle.
Let's start with the one on the far left. An acute angle is from 0 to 90.
Funny math.
The one in the middle you said was what?
A right,
How do you know that?
because it has, it's 90 degrees.
How do you know that? Is there anything in the picture that indicates that that's 90 degrees?
No, but it should have.
But, who knows?
I was worried.
Yeah, good. I'm trying to make a point. One thing we cannot assume is right angles. So there's a couple different ways that you can denote right angles, which we'll get to later. That is in fact a right angle, and I meant it to be a right angle, but I didn't put the proper notation on it, which we'll get to later. Right angles are equal to exactly 90 degrees. Pregunta? That's Spanish for question.
Never mind. But isn't so an acute angle is 90 degrees? It's just.
It's up to but not including 90 degrees.
Alright.
Okay.
Not including.
Not including 90, because if it's 90, then it's right.
Yeah. That's
So
right.
Oh, okay.
Yep.
So it's from 0 to 8.
And then, Vanessa, what are you thinking obtuse angle is?
above 90 degrees
To anything? 4 gabillion
to 180.
to 180. And then what happens when we go past 180?
Straight.
We don't. Okay. For our purposes, well, yeah, I'll get to that in a second, Mary, but for our purposes, we're never going to go past 180 degrees. Okay, we will go up to 180 degrees, and in fact, 180 degrees is what's called a straight angle. What does a straight angle also look like?
A line.
A line, correct. However, for our purposes, there are no angles greater than 180. Any problems there? You knew those, right?
Yeah.
Awesome. We talked about this when we dealt with segments. People screwed it up on the quiz. So let's make sure we get this one right. This on the left is the actual angle. Okay, it's a physical object. It's two rays combined at an endpoint. The one on the right, what do you think the M stands for? Measure. That's the measure of angle ABC, so that's a numerical value. 30 degrees, 47.5 degrees, et cetera, et cetera. Whether we put the M in front of the angle or not, we're a little more loosey-goosey with angles than we are with line segments. So if you're going to screw up one of them, screw up the angles, not the line segments. There's a big difference there. We talked about congruency already when we referred to segments. Therefore, we also have congruency when we talk about angles. Okay, and again, same comparison holds true. This is comparing numbers. A 47-degree angle is equal to a 47-degree angle. This is comparing size and shape. If I pick up angle DOG and lay it on top of angle CAT, they're going to match exactly. When we talked about segments, we also referred to tick marks. Tick marks and angles look something like this. You put a little bitty inside each angle. So all the angles with one marking on it would be congruent. If you have multiple pairs of angles, you can change your style here and put in 2. You can put in 3. You could put in, let's see if we get rid of this. You can do pretty much anything just to denote how they match. So another thing I might do is something like this, one with a little in it. I could draw little kitty cat faces in one. It'll be equal to all the little kitty cat faces in the other. Whatever you want to do to denote that those angles are congruent. Question?
Does this wiggle above the equal sign? That's comparing those angles, right?
Yes, that's congruency, that's equality.
Okay.
What do you think that, go back?
Yeah.
Okay. Okay, we good? What do you think that word means?
Something that dissects the angle into two.
Okay, and you use a scary word in there that I don't understand.
Like
it cuts.
I know what angle means because we define that, but you use the word bisector or dissector. Big difference. One is in biology, you dissect a frog. We're not going to be cutting up any dead animals in here. So what's a bisector?
It like cuts something, like the angle.
Good. Let's break it down into the two parts. The suffix sect means to cut. What does bi mean? Two. So bisector would mean to cut it into two halves. Right, it cuts it into two equal parts. There's a big difference between just cutting it into two pieces and cutting it into two equal parts. A bisector cuts it into two equal parts. It's usually a ray, so that's why I included ray in the definition. It doesn't have to be. It could be a segment, it could be a line. It looks something like that. So I started with this angle PQT, and then I ran this bisector through it, which is QR. So QR is the angle bisector of angle PQT, and you can see the two tick marks down here. I chose to use two arcs on each of them to denote that those angles are equal. Question?
So does that mean that they both have the same measure?
You got it. So let's say, for instance, angle PQT was 130. How big is angle PQR? 65. How big is RQT? 65. Suppose angle PQR is 45 degrees. How big is angle RQT? 45. And how big is angle PQT? 90. Two little ones, I know it's obviously not 90, but don't trust the picture. Two little angles together add up to be the big angle, or one of those angles doubled equals the big angle. And then the notation again, the ray QR, so Q is the vertex going out towards R. Well done. All right, so a little bit of history lesson here. This whole thing of geometry that we're doing was created by Euclid in about 300 BC. So back then, mathematicians were like rock stars. So they were celebrities and they got all kinds of perks from being mathematicians. I don't know why that went away. It would be awesome. But he came up with this geometry thing, and then he started bouncing it off of his math nerd friends, and they cleaned it up a little bit and eventually published a book in 300 BC about all of this. When they worked on geometry, they did a lot of what's called construction using compass and straight edge. And so you'll see like these colored designs around the room were all made using a compass and a straight edge. Do you know what a compass is?
Yeah.
That thing, you make arcs with it. We're not going to do a lot of that. In fact, we'll do probably none of that unless we have some free time and we can make pretty designs like that. But that's how they generated all kinds of things. So if we start talking about things like creating a 90-degree angle, they wouldn't just draw it, they would construct it. And they didn't have rulers. Okay, do you understand the difference between a straight edge and a ruler? What is it?
Straight edge is just something that has a straight edge.
I see what you did with that.
And then a ruler has like measurements.
Good. Good. So anything can be a straight edge as long as it has a straight edge. A ruler has to have increments on it that can be measurable. Centimeters, feet, yards, whatever it is you're measuring. They had only straight edges, so they did all this measuring with a compass and a straight edge. We're going to deal with three different things: sketching, drawing, and constructing. We will not do a lot of constructions. They're rather difficult and time consuming. Drawing is when you use a ruler and a protractor. We won't do a lot of that. Most of the stuff we're going to do is sketching. So sketching is exactly what you've been doing in your notes. It's just a quick freehand drawing that gives you an idea of what you're talking about. Occasionally we'll do some drawing, but not too much. We're all done. Any questions on any of that? So we got some new terms today. What were they?
Ray, bisector.
Ray, angle bisector,
Angle.
Acute right
Angle.
obtuse straight.
how's it with?
Acute right obtuse.
Acute, right, obtuse, straight. All right, good. Let me stop the recording here. In case I say something incriminating.